Review solving literal equations. So a literal equation is one that has more than one variable. Most of the time, these are mathematical formulas, like the formula for perimeter, or area of a rectangle, or volume of a sphere, things like that. This is useful when you want to manipulate this equation to isolate a different variable than which one is already isolated. So the general steps. Box the variable you want to solve for. This is really important so you don't lose track of what you're actually trying to isolate. Number 2 is act like all the other variables are just numbers. Instead of being a t or an s, they're just a 2 or a 5. They're going to act like regular numbers. And then you're going to follow the same steps as solving one variable equations. So before we get into these examples, I want to write one on the side here that we've done a lot this year. So we have done something like this, for example, and you are asked to solve for y. We've done that a lot. So if you remember, this is actually standard form of a linear equation. Solving for y puts it into slope-intercept form. This is a literal equation. You are manipulating one form to get it into another. So let's review how to do this very quickly. So if we want y alone, we're going to have to move everything else away from it. So the first thing we're going to move is the added or subtracted things. So this negative 5 here is being multiplied to y. That's the last thing we're allowed to mess with. So we have to get rid of 2x first. So we're going to subtract 2x from both sides. Drop your negative 5y equals. Now on the right, 17 and negative 2x are not like terms. You cannot combine these together because 2 has an x and 17 does not. So all you're able to do is write them next to each other. 17 minus 2x. Now that the y is almost isolated, how do we get rid of that negative 5? Well, negative 5 is being multiplied to y, so I need to divide by negative 5 to get rid of it. Now, you can write this one of two ways. You can either write them as being both divided by 5 individually, or you can write it as a giant division by negative 5. Both are exactly the same result. So we have y equals negative 17 over 5, and now a negative over a negative actually simplifies to a positive 2x over 5. So this is actually a better way because we simplify the minus here in the middle. And that's solving a literal equation. So example 1, solve a equals p parenthesis 1 plus rt for t. So we're going to box what we want, so I want t alone. So that means I'm going to have to get rid of everything else. Now normally we would take this p and distribute it in. But if you distribute in the p, you're making more than one p value. So instead, let's think about what we're actually doing when we distribute. Distributing is actually multiplying. So how do I get rid of the p instead of multiplying it in? Well, the opposite of multiplication is division. So we're going to divide by p. So this becomes a over p. Since I don't know what a or p actually the number is, we're going to leave it alone. Then we have 1 plus rt. Now again, we want to solve for t. So r is the last thing I'm allowed to mess with. So get rid of the 1 by subtracting. Now again, a over p and negative 1 are not like terms. So all we're allowed to do is put them next to each other. Then lastly, again, I need t by itself. So to get rid of the r, I'm going to have to divide by it. Now I'm going to divide everything by r. So let's consider this guy first. A over p over r. A fraction and a fraction is not pretty. So on the side, a over p all over r, that's really dividing two fractions. So that's where you keep the top one, flip the bottom, and multiply. A times 1, p times r. So what that really simplifies out to is a over pr. Now, the 1 over r is fine the way it is. Then, all that's equal to t. So I have isolated a different variable. These are the exact same equations, just one is manipulated to look a little different. Let's try another one. Example 2. Solve c equals 5 over 9 parenthesis f minus 32 for f. So I want to get this f that's stuck currently inside the parentheses. So again, I don't want to distribute the 5 over 9 because that's going to make your life a little harder. Instead, let's rewrite this for a second. Remember, this is really all over 1. And when you multiply fractions, you multiply top to top, bottom to bottom. So I can rewrite this as c equals 5 parenthesis f minus 32 all over 9. 5 times the top, 9 times the bottom. Now, just like regular equations, I have to get rid of this division by 9 before I can worry about the numerator. So to undo division by 9, I'm going to have to multiply by 9. So we end up with 9c equals 5 parenthesis f minus 32. Now again, don't distribute the 5, you're going to make your life harder. So instead, I need f, but instead this is really multiplying. So to undo the multiplication, we're going to divide by 5. So 9c over 5 equals f minus 32. Now I need f alone, so add 32 to both sides to isolate the f. I can't add 9c over 5 and 32, so we're just going to write them next to each other. And then equals f on the right-hand side. And that is what we wanted to isolate, and f is now alone, so this is the final equation. Solve h equals 62.4 ns over 33,000 for n. So I need n alone. That's this guy right here. So I'm going to rewrite this just to have some space to work. 62.4 ns over 33,000. Alrighty, we want n alone. Again, n is on the numerator, and I can't mess with the numerator until I get rid of the denominator. So to get rid of division by 33,000, I need to multiply by 33,000. So those are going to cancel. So we get 33,000h equals 62.4 ns. Now we need n alone. So all three of these are all sitting next to each other. 62.4, n, and s have no operation between them. So what that means is all of three of these are being multiplied together. Well, to undo multiplication, we're going to divide. Since they're all being multiplied, I can go ahead and divide by more than one thing to get rid of two things at once. So I'm going to have to get rid of the 62.4 and the s. So I'm going to divide both sides by 62.4 and the s. So the 62.4 will cancel and the s will cancel, leaving us only with n on the right-hand side. On the left, we can just leave 33,000h over 62.4s alone. And now we have n isolated. Again, we don't know what h and s are, so we can just leave this alone without having to work through it any further. Solve f equals g m sub 1 m sub 2 over d squared for g. So just like the previous example, I'm going to rewrite this just to have some space to work. Now m sub 1 and m sub 2, those subscripts are just labeling the different types of m's. So they're not the same m. They don't do anything. Now d squared, that 2 is an exponent. So d squared does mean d times itself. But we're not going to have to worry about that because we want g isolated and not d squared. So we have to get rid of that d squared. Since it's on the bottom of a fraction, we're going to multiply to get rid of it. So d squareds on the right will cancel. So I get d squared f equals g m sub 1 m sub 2. Now I want g alone. So just like the previous example, all three of these are being multiplied together. So to undo multiplication, we're going to divide. And what are the two things we need to get rid of? Well, that's m1 and m2. You can divide by more than one thing at a time. So m1s will cancel, m2s will cancel. And on the right, all you're left with is g, which is what we wanted alone. And on the right, we're just going to leave all these letters exactly where they're at. And there's your formula for g. Example 5. a equals 2 pi r squared plus 2 pi r h, and I want to solve it for h. So there's my h. Now I need to get rid of a few things before I can get h by itself. We have to leave this 2 pi r alone for now because these are all being multiplied. That's the last thing I'm allowed to mess with. So I need to get rid of this 2 pi r squared first. Get rid of add and subtract first. So there's really a plus sign in front of this 2 pi r squared that nobody writes. So we're going to subtract 2 pi r squared to get rid of it. So on the right, it's going to cancel. So we're going to have a minus 2 pi r squared equals 2 pi r h. So now we want h alone. So we're going to have to divide because all four of these are being multiplied together. 2 pi r and h are all multiplied. So to undo that, we're going to have to divide by the 2, the pi, and the r. Don't divide by h because h is what we want isolated. That's what we want to keep. Divide by what you want to get rid of. So we're going to have to take this left-hand side and divide by 2 pi r as well. Now notice I put the division bar all the way across both of these terms because you have to divide everything. You can't just divide one or two terms. Everything needs to be divided. So on the left, I don't know what any of these variables are, so we're just going to leave it alone. A minus 2 pi r squared over 2 pi r equals, on the right, the 2 cancels, the pi cancels, and the r cancels, leaving us with just h. And that's what we wanted isolated. Now, example 6 is the same equation, a equals 2 pi r squared plus 2 pi r h, but this time we're solving for pi. Now, if you notice, there are 2 pi's in this formula. There's 2 separate pi's. Well, I can't solve when there's more than one. I also am not allowed to add these together because they're not fully like terms. This first term has an r squared, and the second term has only an r. That automatically makes them not like terms. So I got to think of something else. Well, pi is being multiplied to this term, and pi is being multiplied to this term. So what we're going to have to do is we're going to have to use factoring of a GCF, that greatest common factor, to pull out the pi. Basically, we're undoing distribution. So this a is going to stay in a equals. Now, I'm going to divide out this pi from both of these, and that pi is going to fall to the outside. So on the first term, when I divide out a pi, you're left with 2r squared, because these pi's are going to go away. On the second term, when I divide out the pi, you're going to be left with 2rh. See, if you distribute this back in, if you multiply pi back in, you're going to end up back where you started. That's how you know you did this correctly. So if there's more than one of what you need to isolate, then factor it out if possible. Now, I wanted to isolate this pi, and currently pi is being multiplied to all of this stuff. So how do we get rid of multiplication? Well, that would be division. What do we need to get rid of? Well, we need to get rid of all of this stuff. So we're going to divide by 2r squared plus 2rh, all of it, to both sides. So that means on the left we have a over 2r squared plus 2rh equals, now this 2r squared plus 2rh is going to cancel out, and all you're left with is